In this subsection, we will use a specific example to show you what is a typical power electronic system. So we will use a servo power system. To show you a power electronics example. So in servo power systems, we usually get the power from three-phase AC grid. And this three-phase AC grid is fed into the power distribution unit, so which are composed by line frequency transformers and switch network. To distribute the power. Then after this stage, we will have single phase, for example, 220 volt AC, 50 hertz in China. Then this single phase AC is fed to another stage, which is called power supply unit, PSU. So in the power supply unit, we need to have two stages. One is the AC-DC stage, which convert the single phase AC to a stable DC voltage in the DC bars. And next, we'll have a DC-DC stage, which convert this 400 volt DC to a 48 volt DC. And this 48 volt DC bus, usually we also have a uninterruptible power supply stage. We typically call this as UPS. UPS has energy storage units, so that when the grid interruption happens, we can still use UPS to maintain the normal operation of the server power system. And after this 48 DC bars, we have multiple conversion blocks. So we call those blocks as voltage regulator. Modules, right? So VR modules. So for example, we need to have the voltage regulator modules to convert 48 to 1.2 volt DC to provide the power to the memory units. And also we need to have voltage regulator modules to convert 48 to 1.8 volt DC, 1 volt DC, even lower, 0.8 volt DC, mainly to supply power to the terminal loads like CPU, GPU, and application-specific integrated circuits. And also we need to have voltage regulator modules convert the 48 to 5 volt or 12 volt DC voltage, mainly to supply power to the fan and also the hard drive. And also we need to have voltage regulator modules to realize the conversion from 48 volt to 1 volt, 2.5 volt, 3.3 volt, which provide power supply to the other system rails. So we can see that there are many power conversion units in the server power system. So next, we will extract one of those power modules to show you its internal details. So we take this PSU unit to show you what specific circuit are running in the PSU unit. So for this PSU, we can have the input from a single-phase AC. Then we can install a diode bridge to rectify this AC to a rectified DC voltage here. And on the right-hand side, usually we need to have a boost stage. To regulate the rectified AC voltage to a stable DC voltage, and also to realize the power factor correction. So this is boost power factor correction, AC to DC converter. And to enable higher power level, we usually can install multiple phase boost units in parallel and even in interleaved manner, so they can have advantages. And beyond this boost stage, right, we realized a 48 volt, 400 volt DC voltage. Then we can do the DC to DC conversion. So we can have a bridge inverter to convert this DC to high frequency AC. And this high frequency AC signal is fed to a resonant tank composed by resonant inductor and resonant capacitor, as well as the transformer. So the transformer has a magnetizing inductance, which is Lm. And on the secondary side, we have center tapped configuration and also two rectifying diodes. And a filtering cap to the output. So the output will be 48 volt DC. So this stage can realize the DC to DC conversion from 400 volt to 48 volt. And this is also a very famous topology. We call this LLC DC to DC converter. And similarly as the previous stage, to enable a higher power level, we usually need to have multiple modules in parallel. So that's the complete structure for this power supply unit. So as this subsection shows, in the data center power supply applications, we need to design a high efficiency, compact, and good dynamics power supply unit. So we can see that the modeling and control of power electronic converter is a fundamental tool to facilitate the better design of power electronic converters. So I hope that through the course study in my series classes, I can lead you to learn the detailed knowledge set